Good day, everyone. I am Shannaia Macunay, and today we will be exploring the fascinating world of oscillating systems. We'll be focusing on how different parameters like amplitude, frequency, period, displacement, velocity, and acceleration are related to each other. So, what exactly are oscillating systems? These are physical systems where a part or parts move back and forth, exhibiting periodic motion around an equilibrium point, characterized by periodic motion where the system returns to its initial state after a certain time interval. So this is an oscillating system in a simple pendulum and a mass on a spring. So let's start with amplitude. Amplitude is essentially the size of the oscillation. It tells how far the object moves on either side of the rest position. It's the maximum distance the object moves away from its resting point. A larger amplitude means a more energetic oscillation. So next we have frequency. Frequency is the number of complete oscillations or cycles per unit of time. It's measured in hertz, where 1 hertz is equal to 1 cycle per second. In these figures, it takes 3 seconds to complete one wavelength, but in the first figure, it takes 3 seconds to complete 3 oscillations. In the second figure, it takes 3 seconds to complete 4 oscillations. And in the last figure, it takes 3 seconds to complete 6 wave cycle or oscillation. Period, on the other hand, is the time to complete one full oscillation or one wave cycle. It is denoted by T, and its SI unit is sec or second. Now, let's talk about angular frequency. Angular frequency is the rate at which something rotates or oscillates, measured in radians per second. It's just another way to describe how fast something is oscillating. It's related to both frequency and period by using these equations, where W is the angular frequency of the wave, T is time or period of the wave, and F ordinary frequency of the wave. Displacement tells us where the object is at any given time during its oscillation. For simple harmonic motion, which is a nice, smooth oscillation, we can describe the displacement using these equations, where A is the amplitude, W is the angular frequency, T is time, and O is the phase constant, which tells us where the oscillation starts at time 0. Velocity is the rate of change of displacement, or how fast the object is moving. We can find the velocity by taking the derivative of the displacement equation. The object moves fastest when it passes through the equilibrium position and slows down as it reaches the maximum displacement. Acceleration is the rate of change of velocity, or how quickly the velocity is changing. We find the acceleration by taking the derivative of the velocity equation. The acceleration is greatest at the point of maximum displacement and is always directed towards the equilibrium position. This is why we have a negative sign in the equation. So putting it all together, frequency and period are inversely related. Angular frequency